Okay, I would like to share with you two more examples of solving an exponential equation and then solving an equation with a log in it. Because I showed you some examples where they turned out to be nice, like example 1, let me show you when you can't rewrite it or remind you from Algebra 2 how you would use a logarithm to drop an exponent. So I have 5 plus 2e to the x equals 21. So as an example 1 on the previous video, we need to first isolate the base. So I'm going to subtract 5 from both sides. So 2e to the x equals 16. Then I'm going to go ahead and divide by 2. So I have e to the x equals 8. Now previously, we had numbers that I could rewrite them using a power of 2. There's no way that I can rewrite 8 as an exponent of e. So at this point, what I do is I use one of my logarithm powers to bring this exponent down to the front. And I am going to use the natural log, and I'm going to take the natural log of both sides. What that does with this x from a couple days ago is it really brings the x to the front. So I have x times the natural log of e equals the natural log of 8. And if this was something other than e, we would actually have to use our calculator to calculate it. But you need to understand that the natural log of e is 1, because e to the first power is e. If you forget that, that's fine, but I expect you to know that e, the natural log of e is 1. So if this is 1, that just is x times 1, or x. So x is equal to the natural log of 8, and the natural log of 8 would be approximately 2.079. So I have an approximate answer here for my solution. Let's do one more solving question, and this time let's solve a logarithm question, not like the one where there was multiple logs, but just when there's one logarithm. How do I solve something like that? So let's solve 2 times the log base 3 of x minus 3 equals 4. Once again, on the previous page, I told you to isolate the log, okay, which means this is the log expression, this whole thing. I need to get it alone on this side. So the first thing I'm going to do is I'm going to go ahead and I'm going to add 3 to both sides. So now I have 2 log base 3 of x equals 7. And technically, the log expression isn't really isolated yet because I have a 2 times in front. So I'm going to go ahead and divide out that 2, which gives me log base 3 of x equals 3.5. Once we have our logarithm isolated, and there could be a number in here, it can be, I'm not a number, but x plus 7 or x plus 8, or it doesn't have to just be an x. Anytime I want to get rid of a log, what I'm going to do is I'm going to rewrite it in exponential form. And so again, from yesterday or 2 days ago, we do that by taking our base, so our base is 3, The exponent is on the other side of the equal sign, and that is what is equal to x. So we go ahead then and raise 3 to the 3.5 power, and we get x is approximately 46.765. So 2 more examples just to give us a little bit more of a refresher on how we solve exponential equations and logarithm equations.